In this example, we're going to evaluate this definite integral, and we're going from 1 to e, and our integrand is the natural log of x, and that is being cubed and then divided by x, of course, with respect to x. If you'd like to try this, go ahead and pause the video and do so, and then come on back and we'll work it together. Okay, so looking at this integrand right here, I see that I have a natural log of x, which is kind of a function of itself, but that's being raised to the power of 3. So it seems like this might be a great candidate for a U-substitution. So I'm going to say u equals the natural log of x, and I'm going to go ahead and differentiate both sides. So du equals 1 over x dx, and then let's solve for this dx and see what we have. I can solve for the dx by multiplying both sides by x. So I'll have x du. Okay? Also, when we use a u-substitution with a definite integral, I also need to change these limits of integration. So if my u is going to be the natural log of x, I need to look at those limits of integration. So the first one was 1, and the upper limit was e. So we need to go ahead and plug these in and see what the associated u value will be. So let's plug 1 in first. So the natural log of 1, well, that's going to be 0. And then plug an e in. So natural log of e, and that's 1. So instead of going from 1 to e, now we're going to go from 0 to 1 because we changed those limits of integration as well to accommodate our change of variables into u's. Okay, so my integral is from 0 to 1, and this natural log of x is now my u, so it's u cubed over this x times, and this dx turned into x du, so it looks like these x's will cancel one on top and bottom. So what do I have now? Well, I have the integral from 0 to 1 of, well, it looks like u cubed du. So not too bad at all for this one. So what is the integral of u cubed? Well, it'll be u to the 4th over 4, and we're going to evaluate that from 0 to 1. And so let's plug the 1 in first. So 1 to the 4th is 1, so 1/4. And then plug the 0 in, and I just get 0. So 1/4 minus 0, that is going to be 1/4. So when I evaluate this definite integral, I used a quick u-substitution. I had to change my limits of integration as well, and when I did so, I integrated and I evaluated and I got 1/4.